Yeah, let us discuss about the dual band highly miniaturized patch antenna. Yeah, let us discuss about the abstract of the product. So, a microstrip patch antenna is a low profile antenna. It has a number of advantages over than other antennas. So, they have the capability to integrate with microwave circuits, and therefore they are very well suited for applications such as cell devices and WLAN applications. So, WLAN applications means that is a wireless LAN networks and the navigation systems and many others. So microstrip antenna has many advantages over than other than. So it is lightweight and then also inexpensive, and the electronics like local area networks can be integrated with patch antenna easily with the communicator. So in this proposed work, the highly miniaturized dual patch antenna was designed by using the HFSS software. So the miniaturized technique is used to based on the combination of shorting pin and defected ground structure. So that is called a DGS. So the shorting pin is propagated with ground plane and the a particular patch antenna. A dual band frequency is obtained by using a U slot in the ground layer. So that is a U slot in the particular ground layer, that is called a DGS. So the DGS is a defective ground structure. So the this process, the dielectric of substrate is 4.4, that is a F4 substrate is used in the antenna, and then the radiation pattern and then directivity return loss VSWR. So that is a voltage standing wave ratio and then bandwidth of the proposed antenna or these are calculated by using the HFSS software. So the HFSS is the high frequency structure simulator. By using the design and then calculating all these results and comparing those results by using the existing system of the antenna. So the highly miniaturized dual patch antenna is designed by using the HFSS design. Yeah, let us discuss about the flow diagram of the process. So these are the overall flow diagram and the structure. First of all, we using we should be open the HFSS software, so that is a high frequency structure simulator software, and then we create a new design. So whatever it may be, we design. That is a new blank page will be displayed. So that is a create a new project design, and then substrate model in design. What in the process, particular process, we using the FR4 substrate. So like that, there are different structures, so just like that. So substrate model and the design will be used. The pages will be displayed like the substrate and then select the patch model. So here we using the rectangular patch antenna. So here we using the rectangular by using the dimension x and y process whatever it may be in the given paper. So that is like that, select the patch model, and then the shown in the figure by using the this is a page of the substrate and the patch. So substrate is like in the sandwich model. So substrate is in between the layer, between the top antenna and then bottom of the ground. So in the substrate, we using the FR4 substrate. The dielectric constant is 4.4, and then and then patch antenna. Here we using the rectangular patch antenna in the top of the substrate. So this is the process of creating the substrate and the patch, and then to design the bottom and top. So here we be using the top model, and then here we using the bottom. So here we using the bottom model is like a DGS, so that is a defective ground structure. By using the U slot, that will be displayed like, yeah, this is the DGS design. So like a U slot, so U slot design will be displayed by using the ground plane. So here we using the substrate, top and bottom. So the top and bottom like that, top antenna is a patch antenna, and then the bottom we using the defective ground structure of the process. And then we assign the boundaries and excitation. So in boundaries, we using the perfect electric field. Electric field must be passed in the top patch antenna and then also a bottom patch antenna. And then excitation. So excitation, here we using the coaxial feeding. So coaxial feeding by using the wave port analysis. Coaxial feeding, it must be given to the top of the and then top to bottom of the antenna. So the excitation will be must the wave port antenna will be displayed. So let's figure is shown in. Yeah, this is one type of coaxial feeding, yeah, and the bottom of the process. So that is a the inner ring is a coaxial probe, coax pin, and coax outer coax. So this is called a coaxial feed by using the excitation of wave port. And then we calculating to set up the analysis, like then assign the frequencies, whatever it may be. We calculating the frequencies like in the gigahertz or terahertz. So whatever frequency we will be assigned, and then to assign the vacuum of boundary for radiation. So radiation means to protect the environment by using the antenna. So to protect the environment, to assign the vacuum boundary of the radiation. Finally, we get the results like radiation pattern, return loss, VSWR, and bandwidth. So all the results, particular process we will calculate it by using the HFSS software. So these are the overall running procedures or in the flow diagram of the process of the operation. Yeah, let us discuss about the running procedure of the process. So this is the open type of HFSS window. This is the blank window. Here we using the open design. Whatever may be design will be open. So here we using a dual band miniaturized patch antenna, that will be design will be open. So let's take a time to open the process. Yeah, now I will open the design of dual band circular minimesh patch antenna, and then the process will be outgoing the rectangular patch and then the value of the discussion. So here is the validation of the process. So design settings, 3D model and boundaries and excitation, and then calculate the analysis setup and then optimizing radiation setup. So here we using the validation checkbox, and then this is the overall run analysis all. Here we clicking the analysis all the process will be run, and then finally we getting the results of return loss, VSWR, bandwidth, and the radiation pattern of the patch antenna. Here these are the running procedure of to how to run the process, and then finally we discuss about the results. So the results are must be in the calculated in the form of waveforms. So the results are, yeah, this is the return loss of the graph. Minus 10 is a particular, below minus 10 is a working condition of the antenna. So this is the point of for example, this point is indicated at 2.4 GHz minus 15 dB, and then M4 is a 2.7 minus 17 dB. So here like that, this is the return loss of the plot, and then gain total. So this is the 3D plot of the polar gain. So the polar gain we're calculating the 3D x and y is an axis, and then finally calculate the radiation pattern. So radiation pattern here we obtain the pi 180 degree to obtain all the degrees. For example, 1 degree means that is a pi is equal to 0 degrees. So the frequency must be 9.112 GHz. So this is the plotting of the radiation pattern, and then this is all one type of a radiation pattern return loss of the process. So this is all the type of the directivity by calculating the results. Here we are using the directivity of the process, and then finally calculated the return loss of the process, and then must be directivity in one dimension of the antenna. So we have many results are calculating the create model and then solution term. So by using the rectangular plot, here we are using the terminal VSWR and then dB by calculating a new report. We calculating the VSWR antenna. So this is the VSWR of the process. Here we are using the marker and we'll calculate the 2.793 and then calculate the 1.97. So these are the overall running procedure of the process. Thank you for listening this video.